Hey everyone, welcome back. Today we're going to tackle a classic LeetCode problem, number 8, string to integer, also known as atoi. At first glance, this problem might seem simple, but it's actually a great test of how well you handle edge cases and process strings step by step, just like you might have to in a real-world back-end system. So here's what the problem wants. You're given a string, and your job is to convert it into a 32-bit signed integer, just like the classic C function atoi. But of course, there are rules. So let's walk through them. First, we need to ignore any leading spaces. If there are white spaces at the beginning of the string, we skip over them. Next, we check for a sign. Is the number negative or positive? If the string has a plus or a minus right after the spaces, we capture that. Otherwise, we assume the number is positive. Then, we start reading the digits. As soon as we hit a non-digit character or the end of the string, we stop. Finally, we clamp the result to make sure it fits inside the 32-bit signed integer range. If it's too small, we return negative 2 to the power of 31. If it's too large, we return 2 to the power of 31 minus 1. Let's walk through an example together to really understand how this works. We'll use the input string like this. To solve this, we first need to set up a few things. We'll create a variable result to build the number, a sign variable to track whether it's positive or negative, and an index to keep track of where we are as we scan through the string. Alright, let's begin at the very start of the string. Our string starts with several spaces. So we move the index forward one character at a time until we hit a non-space character. By default, our sign variable is set to 1, assuming the number is positive. This sign will later be multiplied with the number we build to determine if the result should be positive or negative. If there's no explicit sign character in the string, we just assume it's positive. That's why we initialize sign to 1. But since we've encountered a minus sign, we update sign equals negative 1. And then we move the index forward again. The sign character takes up space. Now we're looking at the digits. Here's where we build the number using base 10 logic. For every digit, we multiply result by 10 and add the new digit. So we go like this. After that, we reach the character C, which is not a digit, so we stop right there. Now we multiply our result by the sign. Let's make sure it's within the 32-bit signed integer range. In this case, minus 33.7 is totally fine, so we keep it as is. And that's it. We return minus 1337 as our final answer. This example shows how each part of the logic works, skipping spaces, detecting the sign, building the number, and stopping at the right place. It's all about clean, careful passing, one character at a time. Easy, right? But the key here is to implement this process exactly as described, including all the edge cases. So let's think about how to turn that into code. We'll start by initializing 3 variables: index to track our position in the string, sign, which starts as +1, and result, which begins at 0. Now, we move our index forward until we hit the first non-white space character. Then we check, is this character a plus or a minus? If it is, we update our sign and move forward again. From there, we start reading digits. While the current character is a number, we convert it from a string to an integer and build up our result using basic base 10 logic. Multiply the current result by 10 and add the new digit. We keep doing this until we hit a non-digit or reach the end of the string. Once we're done collecting digits, we multiply the result by the sign, and finally, we clamp the value to make sure it stays within the 32-bit integer range, from integer max value to integer minimum value. If it's outside that range, we just return the min or max value instead. That's it. Now when we run our function, It should handle all kinds of inputs, ones with leading spaces, missing signs, extra characters after the number, huge numbers that overflow, and even empty strings. This is one of those problems that's not just about getting the right answer, but getting it the right way. Clean, step-by-step, and robust. It's the kind of question interviewers love because it shows your attention to detail. Good luck, and I'll see you in the next one.